Tom, welcome to the Get Harder podcast. It's great to have you on.
Thanks, Nick. Good to meet you.
But as I mentioned off camera, I've read your book. I've been following you for a couple of years. Very, very interesting philosophies and theories, which are very different to the mainstream medical system. I'd like to start with discussing different health concerns, if this is okay by you. The reason being, many of my listeners always ask me about different things that maybe challenging them. And I'd like to start with atrial fibrillation because I have read your book around the heart, and the heart is not a pump. So if you don't mind, I'd like to discuss, first of all, atrial fibrillation and your thoughts around that.
Yeah, I mentioned this, Nick, but in order for me to answer a question like on a specific illness, I have to do some background. Otherwise, it really just doesn't make any sense. And that will be more confusing than, so
Perfect.
if that's okay.
Absolutely.
The first thing that I came to, so I'm trained as a medical doctor and I have had a practice for 37 years and worked a little bit as an emergency room doctor. So I only say that to say that I'm familiar with the rap. You know, I'm not somebody who doesn't know what normal medicine thinks. So when it comes to the heart, and you say, well, what did we learn about what the heart does? Because if you're talking about atrial fib, and then if we talk about what causes heart attacks and high blood pressure, it's like I say, if you go to a mechanic and you say my car doesn't stop at the red light, I think they have red lights in Australia,
Yeah,
and you
we do.
say, "Can you take a look at my brakes?" And the mechanic says, "What's a brake?" You probably want to go to a different mechanic, right? Because that's a problem. So we're told that the heart is a mechanical pump. And we're told that the reason the blood moves around the body or circulates around the body is because it's pushed through the blood vessels by the heart. Now, there's a lot of different kinds of pumps. So when I say the heart isn't a pump, what I mean by that is a pressure propulsion device, which means that the reason the blood moves is the heart is generating pressure and that propels the blood around the body, right? Because again, there's other kinds of pumps, but we're not talking about that. This is the kind of pump that I was taught, and every doctor I know was taught. So the other thing that I want to say is, and I didn't learn this in school, and I learned it the hard way, is that in science, and I would also say in logic and thinking, you don't have to know what is true to know what isn't true. In other words, science is a process of there's a claim being made. In this case, the heart generates pressure, which propels the blood around the body. And it doesn't matter if I know what makes the blood move or not. And, the way I demonstrate this to people, I'm sure you've heard this. If you're an 18-year-old Asian fellow, your parents are Caucasian, and then you find adoption papers in their closet, and you go to your mother and say, "What? You never told me I was adopted." Yeah, we got you from an orphanage in China, and we didn't want to tell you, et cetera. And it's all true, right? So you were adopted. And then you go to your best friend and you say, "I just found out I was adopted." And he says, "Who are your real parents?" You say, "I don't know. They got me from an orphanage." And he says, "Until you tell me who your real parents are, I don't believe you were adopted." That's like nutty because he may never find out, and it has nothing to do with whether he's adopted or not. Right? That seems clear?
Yeah, absolutely.
Okay, so pressure propulsion device. So the first thing I looked at is, so we're told we're 60,000 miles of blood vessels in a person. There's,
Oh,
the heart there's the arteries and then goes to smaller and smaller and then the capillaries and then the small veins called venules and then back to the big veins and then back to the heart. So, and it's filled with this kind of sticky fluid with stuff in it, like red blood cells. Interestingly, the red blood cells are approximately the internal diameter of the tubes. which is interesting. And I thought, how does a 1 pound organ generate enough pressure to push all this fluid all the way around the body? That doesn't mean it doesn't, but that's like if you do a pressure diagram, it's like 300 times the amount of pressure that we say the heart generates. Now, the next thing was, it turns out if you do a flow diagram and look at the velocity of the blood at different places, the fastest is when it's going into the heart and exiting the heart. And those are the same. And then it goes slower and slower and slower. And then it gets to the capillaries and it stops, right?
Yeah.
Because it has to offload food and pick up waste products, and then it gets back going again. And so again, I just said to myself, that's weird, because what is it doing if it isn't making the blood move faster? And anyways, if the blood stops halfway through its journey, how did it get back going again? Or in other words, if I'm going to take a bus from Los Angeles to New York and it stops in St. Louis and there's no engine in the bus, I'm not getting in the bus because I don't know how it's going to start going again. And anybody would put the pump where the water stops or the blood stops.
Yeah, correct.
Not where it's already moving.
Yeah.
So that's weird. The next thing is when you look at the outflow tube of the heart, right? The blood goes to the, right atrium, right ventricle, they say, then goes to the lungs, and then left atrium, left ventricle, and then it goes to the body. And the outflow tube of the left ventricle is called the aortic arch. I think you can see me, but it's shaped like an arch, just like any arch.
Yeah.
I used to work in a cardiac cath lab where we put the dye in and watch it go through the heart. And if you're going to generate like an enormous amount of pressure, imagine you have a spigot on your house and a garden hose that's shaped like an arch and can move, right? If if the water isn't going through, it's like this. And if you turn it on full blast, it would straighten, right?
Yes.
Obviously.
Yes.
So when I looked at the arch during systole, because it can also move like this, when it's the supposed push is, it bends in. And I remember asking the cardiologist, like, how come it bends in? Like, that can't happen. If the blood is going through at a huge pressure, it's got to straighten the tube.
Yeah.
He said, well, that's the way it does. And I said, I know it's the way it does because I can see it, but that makes no sense.
Yeah.
So there's some other things, but that convinced me that this isn't possible. And then actually, since I wrote the book, I ran into this, the best model of the heart is by this Spanish cardiology, Torrent Guasp, who unrolled the heart, and it's actually one continuous band. And what he was able to show is that the heart goes down to, as if it's like a plunger in your toilet, plunges down, and then it plunges up. And that creates a suction, which helps suck the blood up to the heart. And this creates a vortex inside the heart. And that suction is why the tube pulls in, the arch pulls in. Because essentially, if you imagine the blood coming into the heart, and then there's like a dam. And so the pressure builds up on the incoming side, and then there's a vacuum on the outside, right?
Yep.
And that will suck the tube in. And when the pressure differential is big enough, the gate opens, it vortexes down, the blood falls down to the capillaries, and then it stops, and then it gets going again. Now, the question then, how does it get going again? I don't know if we want to get into that because we're getting far away from atrial fibrillation.
No, it's fine. It's fine. I'm fascinated.
So, right. So we know that the heart stops the blood, creates a vortex. That creates an electromagnetic field around the heart. which you can actually measure and map, and it's a toroidal field. Interestingly, just like the toroidal field around the Earth, which is a whole nother subject. And interestingly, the heart and the Earth are anagrams of each other, meaning just rearrange the letters and you get, so that's interesting. So the heart, by doing this suction, damming up, creates a vortex. And, you know, the Sufi said this vortex is where the God enters into the human being. Now, I don't know if that's true, but vortexes is how creative energy becomes physical, right? That's how a plant uses vortex, and we have a vortex on the top of our head. And this vortexing, which you can actually see in the blood, you know, they've done MRIs, they can see the blood moving in a vortex in the left ventricle. And that creates this field around the heart. And then the blood is essentially, you know, falls down to the capillaries, and then it stops. Now, how does it get going? So it turns out another thing we learned, which isn't true, like most things in so-called science, is, I don't know when you learned this, but matter exists in three phases: solid, liquid, gas. So you have copper, you have solid copper, you have molten copper, and you can make it into a gas. So with water,
physics.
the what?
That's a grade 7 physics. So we learned that. Yeah.
There you go. So water is ice, water, and steam. Now, I remember, you know, because I was an ER doctor, they told me that 70% of us is water. All in your cells is water.
Correct.
So I see people, so I said, okay, it's not ice, right? Because that's weird. It's not steam, so it must be liquid water, right? Because that's the only choice there is. So I see people get shot and bayoneted. You know, I'm an ER doctor then. And I never saw anybody squirt water out of their body. Then I found out, so if you say, well, what is Jello? I don't know if you guys know Jello, but
yeah, we call it jelly. Yeah.
It's 97% water, they say. So what phase is it in?
It's in gelatin.
Yeah, but it's a multiple choice. You only got three options.
Well, it's hard because it doesn't leak water. Solid.
Yeah, it's not water, it's not steam, and it's definitely not ice. And so it turns out that water, and only water, has four phases. And it's called a gel phase or coherent water, structured water, a lot of different names for it. And that's all life is in this structured phase. All life. That's what life is. That's the definition of life. And when your water becomes liquid, like you get swelling on your legs or your knee, that's a problem. Because so it turns out that all gels are negatively charged. And so if you make an experiment, you put a beaker of water and you hang a tube horizontal that's hydrophilic, so it interacts with water, it will form a negatively charged gel inside the tube. And that separates the charges like a battery. And so the so-called positive, that's not really right, but you could call it positive charges go into the liquid water and it starts moving because they repel.
Yeah.
And so that's what happens in the capillaries. You have a tube, you have liquids, water like blood, and then it interacts, forms a gel that protects the capillary, and it forms positive charges in the middle, and they start moving, and they get the blood to start moving, and then it coalesces from like a wetland to a river, and that makes it go faster and faster, and it goes to the heart. Heart stops the blood, does the vortex thing, falls down to the capillaries, and then gets moving again. It's very simple.
Got you. So you basically, okay, and you've also touched on that structured water is life. Would you mind discussing quickly what structured water is?
Structured water is this gel phase water. It's what happened. Now, so even to answer that, you can then measure how robust the structure of the water is. You know, how big a gel you have. So you can put water in a beaker with a tube, and you put it in the sun, and the water goes faster. because there's more of a gel. And then you put it on the earth and it goes faster because there's more of a gel. And then you put your dog next to it and it goes faster, at least most dogs. And that's because living things help with the energy of structuring the water. You put your hands on it, it goes faster. You put your cell phone next to it and it stops moving. Now, when the blood stops moving, it just falls down. Because that's what we call congestive heart failure. It's not got anything to do with the heart. It's got to do with the pump is broken, meaning the water isn't moving from the periphery back up. So it falls down, it falls into your lungs, and they say your heart is broken, congestive heart failure. But the pump is broken, and the pump isn't the heart, it's this movement of the water.
Because our body's electrical and structured water.
Yes.
With electrics.
Yeah.
Okay.
We are a bioelectric organism, not a biochemical organism. And that's so basically when the voltage is low, because you're interfering with the thing that creates the electrical impulse, which is the interaction of the electromagnetic field called the sun and the earth and other humans and your hands and connections with people and good food and all that. If you disconnect to that and connect with toxic things, you destructure the water and then you get sick. Now, so in the heart is the organizer of that electromagnetic field. And it does that through this vortexing action and, interestingly, through the iron that's circulating in the blood. That creates a magnetic field, which we can actually measure. So then you get to your question. So what is atrial fibrillation? They say that atrial fibrillation is when the normal pacemaker part of the heart is sick. That's called a sinus node. And so the body then says, oh, we're not getting the impulses in the normal way. So it sends out distress signals, which means different places fire, abnormally, and then you get atrial fibrillation. Now, interestingly, all things, this is the key message here. All of the symptoms, all these so-called diseases are the body's way of fixing a problem. In other words, if your electrical system isn't right because you're not connected to the sun and the earth and you're not eating good food and you're not moving and your life, you're poisoning yourself, etc., then your electrical system doesn't work and your body compensates by sending off distress signals. And that's good because otherwise you wouldn't have any beat at all. But it's also inconvenient, right? You'd rather have the normal beat than distress signals. That's why, when they say, oh, they can't treat atrial fibrillation. All they can do is stop the speed.
By burning the heart.
Yeah, by poisoning the heart, then they can stop the speed. Or they can try to burn out these areas that are firing, but it doesn't work because you burn out one area and the heart says, okay, well, I have to have the next area send out a signal. The problem is this field that's supposed to be like 6 feet around us and robust, that's our electromagnetic field, has actually shrunk into become closer and it's not as robust. And that sends distress signals. And then you get this abnormal rhythm. And it's usually caused by, one of the reasons for this worldwide epidemic is statin drugs, because what they do is poison the heart. They poison the energy field of the heart, and then it gets sick, and then you get atrial fibrillation. So I used to, pretty much everybody I saw who had AFib, it's either statin toxicity, poor food, emotional stress, or EMF exposure that's poisoning them.
Yeah. Because I'm seeing a lot of younger people now having atrial fibrillation,
right.
and they have persistent AF. Is persistent atrial fibrillation reversible, or do you need to have an ablation or go on beta blockers to potentially resolve it?
So ablations basically don't work because it's not an energetic problem. I mean, it's not an electrical problem that you can ablate the nerve. It's just there's an energetic imbalance. Your heart isn't able to generate energy, so it sends out distress signals. And that's what we call atrial fibrillation. So, uh, so that doesn't work. They know that. And beta blockers don't treat AFib, they just slow the rate down. So there is no, just like anything, because they don't know what the problem is. And they don't, it's interesting because if you say to a doctor or cardiologist, don't you think the heart is an electrical organ? It works basically as an electrical impulse. They say, no, that's ridiculous, just a muscle. So then you say, well, how do you know if the heart is normal? Well, you do an EKG. What does that measure? The electrical activity of the heart. You say, wait a minute, I thought you just told me it wasn't an electrical organ.
Doesn't make
Anyways,
sense.
it doesn't make sense. It is an electrical organ. It generates an electromagnetic field that organizes the electromagnetic field of the whole body. It's like the conductor of the symphony. So yes, if you take somebody who's got atrial fib and you take them off, they have to be off all the pharmaceuticals. They have to eat a good diet. They have to connect with the sun and ground to the earth and work on whatever, emotional, psychological barriers have led to this. They're often sort of closed-hearted, or they had a shock to their heart or something happened. So that has to be addressed. And then there's some medicines that help energize the heart, like strophanthus.
Yes. Would you mind telling everyone about strophanthus? Because in Australia, it's not known, and I think it should be. So I'd love to hear more about it.
I mean, strophanthus it's a seed that originates from Africa, Madagascar. It's like coconuts. So it grows on these big vines, and they have pods, and they have hundreds of seeds in the pods. And the seeds have been used as a heart tonic for at least 100 years. And in conventional medicine, this is well known because it used to be the treatment for AFib and congestive heart failure and what are called, heart attacks and angina, unstable angina. And it still is to a certain extent in Germany. And it's a source of what they call a cardiac glycoside, which is a medicine that stimulates and energizes the activity of the heart. Now, it turns out they get the mechanism of how it works completely wrong because they say it inhibits the sodium potassium pump, which turns out doesn't exist, and that increases the calcium in the sarcolemma reticulum, which sarcoplasmic reticulum, turns out that doesn't exist either. But what it does is strophanthus seems to organize the water to make it more structured. When you have structured water, you have a stronger charge, and that's reflected in the sodium potassium inside and outside the tissues. And that's what causes the charge in the heart. And you have a more energized, charged heart. And so that creates a stronger electromagnetic field. And then you don't have to have chest pain or, have so-called congestive heart failure or have distress signals that we otherwise call atrial fibrillation.
How would someone create structured water? Because most people don't have a river in their backyard. So how would someone at home go, okay, I'm going to start drinking structured water? How would they do it exactly?
So there's a guy in Australia, I think he may be New Zealand, but Rob Gourlay, who has done a lot of work on structured water and what he's determined is that all the healing waters like Lourdes and there's healing springs all over the world, they have a certain charge. And this is because, it's no longer just liquid water, it's organized water and organized in a specific way. And it also has to have minerals in it because distilled water, like the battery of your car, doesn't hold a charge, right? You can't use distilled water. You have to put so-called electrolytes or ions or things like calcium,
Electrolytes.
sodium, magnesium. Yeah. So he has a device that it's basically a vortex with magnets, and you spin the water, any water, through vortex and magnets, and then if you do it 4 times, you create a similar charge as with like Lord's water.
Mhm.
Now, it doesn't necessarily mean because you drink structured water that the water in your body is going to be structured. I mean, it might help, and it probably does help, but in order to have the water be flowing, the fluids be flowing, therefore meaning they're structured, you have to have adequate minerals, and you have to be exposed. Humans are like, all living things are like batteries. And the
Sun.
charge is the connection between the sun and the earth. That's how I used to treat people with AFib and congestive heart failure, is increase their minerals, structure their water, and tell them they had to go outside and connect bare feet on the earth and in the sun as much as possible for at least an hour a day. And that would charge the water in their blood. It would start it moving again, which stopped the distress signals. And, I never had to treat anybody with pharmaceuticals for AFib and congestive heart failure, because that's the principle of how it works.
But that goes against everything the medical profession is taught. Sun, grounding, and structured water, it doesn't cost anything.
Doesn't
It's free.
cost any. And you need some minerals like, seawater, and there's all different kinds of good salt, that's not like processed and purified. So,
Wow.
right, it's simple. And don't
Yes.
poison yourself. And you can poison yourself, statin drugs for one, beta blockers for another, calcium channel blockers. But you can also poison yourself with hatred and delusions. Like even the delusion that you think you're a mechanical pump. That's not true. And thinking of yourself like that is a bad strategy.
Okay, but the issue is people have been brainwashed a certain way, and to unthink that is a challenge for many.
I mean, right.
Um,
What can you do?
no, what can you do? So, from your personal experience, do you think most diseases are reversible with light, structured water, grounding? For example, Hashimoto's and Graves' disease, which impacts a lot of young people these days. Do you think these conditions could be reversed with these modalities?
So the big so-called psyop here, or the big delusion, is there are specific diseases which need specific treatment.
Mm.
That's not true. Let me give you an example. If you get a splinter in your finger, what happens?
It becomes inflamed.
Right, red and pus, right?
Yes. Yeah.
Is the red pus inflamed and pain? Is that the therapy or is that the disease?
That's the body trying to solve the problem.
Right. So it's the
Yes.
therapy for a splinter.
Correct.
And you can prove that because once it gets the splinter out, the whole thing goes away.
Correct.
Okay, next one. You breathe in some stuff into your lungs, cigarette smoke, chemtrail dust. You live in some city in China and they have all this pollution in the air, and you hold in your tears and your emotions. And so you get all this buildup of debris in your lungs. Then you get a cough and mucus and you feel bad and a fever. Is that cough and mucus and feel bad, is that the therapy or is that the disease?
That's the therapy.
For getting the debris out of your lungs.
Yes. Correct.
Right. So
Yes.
suddenly these things, we go to a doctor, he says you got bronchitis, you have to stop the cough, and so you keep the debris in your lungs. That to me made no sense. No sense.
Yeah.
Now, here's another one. If you have a house, you probably have a house, and you have a foyer in your house, entrance. right? Somebody puts some stinky garbage, open the door, throws it in the foyer of your house. What do you do next?
I throw the garbage in the bin.
How do you get it from the foyer to the bin?
I will lift it up and carry it myself and take it to the garbage.
But you probably put it in a bag first.
Yeah, correct. Yes.
Okay. You put it in a bag, you take it out to the garage, put it in the bin. When the garbage people come, you take it out to the curb and then they take it away.
Yeah.
Okay. And then
Yeah.
you tell them to stop putting garbage in your house.
Yes.
Okay. What happens if you put garbage in the house called your body?
Then I'm gonna remove that through.
You put it in a bag first.
Yes. Yeah.
That's called a tumor. And
Mm,
then you store it. And then you take it out to the curb through bowels, sweating, urine, etc.
yes.
If there's too much garbage, you have to keep making bags. And you make more and more bags. First in your breast or your prostate or your lungs, then in your liver, and then in your brain, and then everywhere. And then you have to move, just like your house.
Yes.
But
Yeah.
that isn't a disease called cancer. That's a therapeutic strategy for somebody who insists on putting more and more garbage in their house.
Yeah.
And that's why every successful cancer therapy has been as simple as this. And everybody listening thinks it can't be that simple. Like this guy's nuts. But everyone, Gerson diet, fasting, everything, Gonzalez program, stop putting garbage in your body, take it out to the curb faster.
Yes.
Fasting, good food, enemas, sweat lodges, enzymes to digest the garbage. There's lots of ways of doing this, but it's all the same principle. And what is normal oncology? They put more poison in, which burns out the garbage, and then you get more and more garbage, and then you die.
Yeah. Yeah. For example, chemotherapy as well,
Right.
which kills everything. Yeah.
So the point of that is when you say, I don't remember the question, but is disease
No.
curable? Well, there is no disease. There's your body's amazing strategies to deal with something that shouldn't have happened. Like you injected yourself with a poison, otherwise known as a vaccine. And so then you have to store it somewhere because you don't even know how to get rid of it. Nobody's ever injected aluminum into their body. Like that's dumb,
Yeah.
right? So
Yeah.
then you store it in your breast or in your prostate, and then you say, "Oh, you got cancer." Now, every disease, the first step is gratitude. Thank God my body had the sense to store this aluminum so it didn't go all over and kill me. Thank God I coughed up that mucus and that chemtrail debris and the smoke and all the rest of the stuff that I've been stuffing in my lungs for 20 years. Thank God I did that. That's the first step in getting better. Once you get that down, the rest is just, helping your body cough it out. Stop putting in the poison, getting it out quicker. And there's very specific ways of doing that depending on the situation.
Would this apply for something like EBV, which is a viral infection? Is it the same theories?
Except, Nick, there's no such thing as a virus. Or let me be more precise in my language.
Please elaborate.
Nobody has ever demonstrated the existence of a virus. Now, let's flesh that out for you and your listeners a little bit.
Yeah.
So, I always ask people the question, do you know how does a virologist prove the existence of a virus?
They do a blood test normally for EBV.
And what are they testing for?
I'm actually not sure what they're actually measuring.
Right. Which is interesting because 99% of the people, including 99% of the medical doctors, including myself, when I graduated from medicine, I did not know how they proved that there was such a thing as a virus. That's shocking. It's shocking to me that I was so ignorant, but I was. So, of course, being me, I go back and I say, okay, how does a virologist show the existence of a virus, right?
Yeah.
Because you don't know. You just
Yeah.
believe they must have done that somehow. They must have pictures or something. I don't know what they did, but they did something. So let's go back and I'll walk you through how they did it, and you can see what you think.
Please.
Okay, so one of the first ones was the so-called poliovirus, right? So they see children who were paralyzed, and they didn't know why. It could be anything. And they at that time said, this was right after Pasteur, early 1900s. Diseases are caused by microorganisms, all diseases. So they looked for bacteria in the spine of of children who died of polio. No bacteria. So they said, it must be smaller than a bacteria and we can't see it, so let's call it a virus. They didn't see a virus. They didn't smell a virus. They didn't taste a virus. They just said, it must be a virus because we don't see it. That's weird, right? Because
Yeah.
so then they said, okay, we can now isolate the virus. And the isolation means find, right? Like if I said to you, how do you know there's a hammer? Well, you go to a toolbox, that's where hammers are usually found, open it up, and you take out the hammer and you have only a hammer. That's called isolating the hammer. And then you can hit it a nail and see if it goes in, then you know what the hammer does. Okay? So they took the spine of a child who died of paralysis, they ground it up in a blender, filtered it a little bit just to get some of the debris out, and then injected it into the brain of two monkeys. One monkey died and one monkey got paralyzed. And they said, see, we isolated the virus. And I thought when I read that, wait a minute. So they didn't inject the normal spine into, I mean, maybe monkeys don't like having 10 cc's of diseased spinal cord injected into their brains. Like, that's weird, right?
Yeah. Yeah.
You don't prove there's a hammer by taking a toolbox and never finding a hammer in it, hitting a nail with the toolbox and saying that proves there's a hammer in it. That's what they did. They did that then for approximately 10,000 more monkeys over the next 50 years. And then in 1953, it's an important date in this story, somebody injected healthy spine into two monkeys' brains. You know what happened? One got paralyzed, one died. He said, oh, well, it turns out that isn't a good way to find the virus, but we have a better way. And then a guy named Enders got a Nobel Prize for finding out how to isolate a virus, which every isolation experiment since 1954 has been done exactly the way that I'm going to describe, including SARS-CoV-2, the alleged virus that caused COVID. They took this they did with measles. They took the mucus of a child with measles. How they know they had measles is a whole other story because they didn't. Anyways, the child was sick. They took some mucus, filtered it a little bit to get the dead cells out, and then they inoculated that, in other words, spread it on a growing monkey kidney cell culture. So they harvested kidney cells, grew that. They put fetal bovine serum, cow serum, horse serum. They put antibiotics that are poisonous to the kidneys, amphotericin, gentamicin, penicillin, etc. They took away the food of the cells, and then they put some chemicals called trypsin in it. And then 3 days later, the kidney cells died. And that's called the isolation of the virus. That's weird.
Yeah. Yeah.
And by the way, the guy who did it, Enders, he said, okay, I'm going to do the exact same thing. The monkey kidney cells, the antibiotics, take away the food, the chemicals, the horse serum. But now I'm not going to add anything with anybody from measles. And you know what happened?
What happened?
He said it was indistinguishable from the first one.
Interesting.
Which means he proved that it had nothing. Not only didn't he see a virus, it didn't even have anything to do with the child from measles. They just poisoned and starved some kidney cells,
Yeah.
and then they died. And that's how they did SARS-CoV-2. They took the mucus, the lung fluid of somebody they said had COVID, they put it on monkey kidney cells, they put the same antibiotics, and the monkey cells died. And they didn't do a control, and that's how they isolated SARS-CoV-2.
But
Now,
if there's
let
no,
me just finish one thing.
please, yeah, please.
So people will say, yeah, but I've seen pictures of it, right? So what they do is they take these monkey kidney cells and they put them in an electron microscope procedure, which means they freeze them and dehydrate them and stain them and shoot an electron, so-called electron beam at them, and then they get a picture. Now, there's at least 20 references in the medical literature that say we did the exact same thing with monkey kidney cells with no measles virus, no measles, nothing. We did kidney biopsies from the 90s. In other words, they just take sick kidneys and they do the electron microscope and they get the exact same pictures. Every virus, so-called, you can get the exact same pictures by just doing the electron microscope procedure on dead and dying tissue. Those are not those are not viruses. Those are just, that's what happens when tissue is dying. And then you can find the genome by taking this dead stuff that has horse serum and you in it, your mucus and all the rest. You can put it in a computer and you can come out with SARS-CoV-2 genome, measles genome, et cetera, any genome you want by just running it in the computer. The whole thing is a fraud. Now, when you say, what is, I always tell people when you get to, well, what do you mean by Epstein-Barr? I say, what is it that you see with that person?
Well, usually you see low white blood count and they're susceptible to getting sick.
So forget about any lab tests. Person comes in and they're tired and worn out and they're feeling sort of depressed and they can't do much. And maybe they get sick a lot, right? That's what you see.
Yes.
You don't see a virus. In fact, by the way, we have now asked approximately 225 different institutions like the CDC and the NIH and the Australian National Health, whatever they call it. Can you show us any evidence of any virus in any biological fluid or tissue of any sick person? And they say no. The only way we can find it is by doing this cell culture thing, which we have already proven is wrong. In fact, we did the experiment where we took, just cell cultures, put the antibiotics in, put the serum in, et cetera, and 3 days later they broke down, indistinguishable from what they call isolation of SARS-CoV-2. There's 20 references in the medical literature, and then they stopped doing it because, you got to stop once you do. Anyway, so now so if you stick to what you see, there's a whole lot of reasons why people are tired and run down and get symptoms like sick all the time.
Yeah. I'm sick right now. So I don't have a virus. I'm run down.
So the important thing is with any of this is to name what you see. You say you're sick. So that means you have mucus coming out of your nose?
Correct. Yes.
Well, that's good because you're getting stuff that doesn't belong in your body.
Yeah, true. I have gratitude for that. I'm grateful.
Yeah. And then you might think about, what did I put in my body that I shouldn't have? Or what did I do that I shouldn't have? And you might even help, do something like take some mullein or something to help your body get rid of it, or not eat for a day, or go out in the sun. None of this stuff has anything to do with the virus.
Sorry, Tom, did you say monolaurin?
No, I didn't say monolaurin.
Oh, sorry, I was thinking monolaurin, sorry.
Yeah, I said mullein. It's an herb that helps you expectorate mucus. In other words, if you stick to what you see and what you actually experience, then you can solve all these problems, and there's no need for any theoretical model called a virus, which nobody can even show exists in the first place. I would even go so far as to say we've disproven the virus model.
But let me ask you a question. So I have the flu, and my daughter just got the flu as well. So did I not pass the flu onto her?
So now we're talking about contagion. So and that, again, let's stick with what we see, because you
Yes.
didn't see anything past, right?
No, I didn't see it, but it just at a coincidence, I got the flu, then she got the flu. Is that a
Okay.
coincidence or is that?
Let me ask you a question.
Yes.
What you saw, and again, I don't want to put words in your mouth, Nick. So if you don't
No, no, no,
agree,
no, no,
don't
no.
agree. What you saw is two or more people, right? You and your daughter have approximately the same symptoms at the same time in the same place.
Yes.
Is
Correct.
that correct?
That's correct. Yes.
Okay. Does that mean that one passed something to the other?
I would presume so.
Okay. You put 100 rats in the basement, and then somebody puts rat poison, and then the next day they all bleed to death. Same symptoms, same time, same place. Are you telling me that's contagious?
No, because it's rat poison. They ate something they shouldn't have.
Right. So, but all you saw was same symptoms, same time, same place.
Correct.
That's what you saw with you and your daughter.
Correct. But it's obviously a massive coincidence, or or I pass it on to her.
No, no, because the rats didn't pass on, and it's not a coincidence. They were exposed to something similar.
Okay.
Now, when you're in a situation, again, I don't want to put words in your mouth,
No, 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 no.
where
This is fascinating.
you can't tell by looking. In other words, all you know is a bunch of rats bled to death. All you know is two people got mucus at the same time and didn't feel well. And you can't sort out what happened. And you know that that doesn't prove contagion, right? Because it could be something in the house, off gassing, or some nocebo effect, or something that you both ate, or some sort of interaction, electromagnetic or energetic or spirit. We don't know. But in a situation like that, you have to do science, which means, okay, you get a situation, you put 100 people in a room, and then you put 10 people with so-called chicken pox or some other, or the flu or a cold, and then the same 100 people in a room with 10 people who don't have that, and you see if you can document that sick people make well people sick, right?
Yes. Yeah. Yeah.
So I know of approximately 200 studies that show that that doesn't happen like that. I know of not a single published scientific paper that shows in the medical literature that shows that sick people make well people sick.
Okay. So
And
so
if
then
you
how?
disagree with that, I don't want to hear a story about Uncle Harry and Aunt Fred or whatever. I want to see a paper showing they've done it with measles, whooping cough, the cold, flu. Guy named Daniel Reuters, he's an Australian, wrote a book called Can You Catch a Cold? 200 studies on is a cold or flu contagious?
Yeah.
Sometimes they do it by having the people breathe in each other's mouth, or sticking snot up their nose, or injecting blood or whatever, and it doesn't work.
Okay.
So
Wow.
now
Okay. So
let me say this one thing. So this is back to the who's your real parents. So we know now it's not contagious. Now, we don't necessarily know what happened to you, but here's some examples. Used to be in this country, they thought chickenpox was contagious. Then they find out that the symptoms of outgassing arsenic are identical to what we call chickenpox. And they used to paint the wallpaper with something called Paris green, which was arsenic, and it off gas. So if you go to this person's house, all the children get chickenpox. If they come to your house, nobody gets chickenpox. And that's how you do science. It's the house, not the people. Now, I don't know what happened in your family, and In fact, every story is an individual situation. But I know that people communicate. You know, you put two 20-year-old women in the room and they menstruate at the same time. Is that contagion? I mean, I don't know. They're living beings communicate, especially things that are good. Like, Nick, it's time to get rid of some mucus. Great. Let's do it together and we can play games and have fun.
Oh, really? So do you think it's almost energy talking to each other, saying, "Hey, I'm unwell. You should be unwell," or I'm trying to comprehend how this could work.
Right. But the thing is, so where what I really suggest to people, if there's anything anybody listening to this gets out of this, is stick to finding out what's not true before you jump to, so it must be this. Now, I can tell you, if anybody doubts me or questions that sick people make well people sick, please send me a study and I'll come back on your show and say I was wrong.
Yeah,
I happen to know there's no chance. So we know it's not that.
Yeah.
And so why is it? I mean, I can guess. I think it's you want to have fun together and do some cleansing and I got that from looking at my daughter, who I probably didn't spend as much time with her as the boys, just because, I played baseball and everything. So she would get sick, and that was the time that I would sit with her and read her stories, and we'd talk, etc. And I got convinced that she was getting sick so that I would, actually be more present. Now, that may not be your situation. That's why even thinking of these as diseases is wrong. They're individual stories of very complex energy beings who communicate in really interesting ways. And I would look there, especially in the things that you can actually experience yourself, not viruses, immune system, all that nonsense. What is the interaction between you and your daughter?
Interesting. No, mate, it's fascinating. This is fascinating theory. Yeah, it's fascinating. I don't know where
It's not a theory, Nick. I'm disproving the claim that there is such a thing as a virus.
Yeah.
There's no evidence for that. B, there's such a thing as sick people making well people or animals sick. There's no evidence for that. There's no theory here.
I'm going to have hundreds of people reaching out to me now, trying to debunk your thoughts on viruses. So
fine, yeah. What they're gonna say is, I saw a picture of it. I can tell you, and anybody who wants to challenge me on this, I have slideshows where I actually I have a cat named Pumpkin. And I showed him these 10 slides of supposedly SARS-CoV-2, right? That's the virus. And I taught Pumpkin to say yes or no. And I said, which one is this? The virus or just broken down lung or kidney cells? And he got 7 right. And I challenge any virologist, any medical doctor, any scientist, any layperson. I'll show you these pictures and you tell me which one it is. Because there is no way anybody can tell. And this has been proven in the medical literature over and over again that this is cell debris stained with an electron microscope. If you're going to tell me that you saw pictures of it, that means you don't know the medical literature.
Okay. All right. So challenge accepted for the listeners out there, if they want to try and debunk this. But Tom, I'm a believer. I'm a believer in your work, and I've read one of your books, and I think, yeah, you're definitely on the right path. Mate, thank you for your time today. I really do appreciate it.